clear, please write down in the chat box. Okay, great. So I'm really excited to start the first webinar from Indian Association of Structural Engineers, Gujarat State Center. We were experimenting this since a long time actually to start this webinar series. And I personally believe that knowledge sharing is really the high priority area for structural engineering field at present. And for this purpose, this kind of webinar series can help us significantly. So while launching this webinar series, we circulated one Google form for registration where you all registered. And in fact, we have received very good overwhelming response from all different parts of the country. And you all have suggested very interesting topic and definitely will be taking it forward sequentially. And right now we have almost 50 participants online. Okay, so I am really very excited to start the first webinar. Okay, so the topic what I have chosen for this first webinar is IAS 800 2007 and software. Okay, first let's try to understand why this topic was chosen. See, I believe that it is a really untouched area presently. And in my short career span, I had a chance to perform design of steel structures for certain complex structures, as well as I had a chance to look into design calculations of different consultants in different parts of the country. And if I quickly share my experience based on that, generally it is said that whenever the design is being performed by latest Indian standard, using limited design method, the tonnage what they get is higher than the working stress design method, which was the earlier code, 1984 code. Also, sometimes I have heard that the practicing engineers do not have confidence while adopting limited design for their structures. So sometimes what is being done that structures are designed using limited design method, and then they are being cross-checked using working stress design method, which is a 1984 code, because software is having both the options. So it is very easy to check, correct? And I believe that still this code is not being followed in totality, even after at least almost 10 years have been passed after publishing the code. So these all kind of scenarios really prompted us to initiate a few exercises where we can understand the root causes and so that we can take the corrective actions, and then that knowledge can be spread for the benefit of engineers. So those exercises are still going on. So we will talk about a few learning whatever we had from that exercise. Okay. This is very interesting figure. It shows brief history of IAS 800. See, on the vertical axis, it shows the level of engineering, and in the horizontal axis, it shows the year. Like if we talk about IAS 800, it was first released on 1956, then in 1962, and up to 1984, it was working stress design method code. And in 2007, when the code was published, the major change happened, which was the limited design method. Correct. Now, in the same figure, if you see the purple color line, it shows the knowledge available in the global industry. So the limited design method was introduced around in 1980s in the American code, and thereafter almost for 5 times, American code was revised in the duration of, I believe, up to 2005. And what we have right now is just only first revision of the code, which is 2007. So definitely there is a big gap. You know, the black color line shows the knowledge which we have in the India, And the purple color line, as we have discussed, is the knowledge available in the global industry. So the hatch color area shows the big gap area, which we need to cover up. Correct? And because of this transition, there are a lot of questions in the mind of practicing engineers. Correct? Like why limit state design method should be used, and whether the structures which were designed using working stress design method were unsafe, or why individual structural engineers should go into more kind of mathematical jargons. And there are so many practical questions we have. Okay. So I believe that these kind of questions can be answered through the philosophical angle of the code. And at the same time, I believe that it is very much important to understand the entire philosophy of the code instead of understanding just only individual clauses. Okay, so this is overall content what we have today. First is the overview of the IAStructE 2007. We'll have a quick recap of IAStructE 2007. Then we will be discussing about IAStructE 2007 and the software, which is the present status. We will be talking in briefly. The third area what we'll be discussing is the areas which can be included in the software. And finally, we will be talking about a small case study, which is a part of the exercises what we were discussing in the beginning. Okay, so let's start with the part 1. It is overview of IAStructE 2007. So let's have a quick journey of IAStructE 2007. Okay. So as you all know, that IAStructE 2007 is having 17 sections, and there are 8 annexures. Correct? Now, this slide shows the total areas or sections which are covered in IAStructE 2007. Like there are sections for different materials. There are sections for different methods of analysis. There are sections for limit state design method, as well as there is an option for working stress design method also, which is available. There are sections for the connection designs. There is also a separate chapter for the earthquake resistant design. There are sections for the fatigue. There are sections for the testing, durability, fire resistance, as well as erection. Okay. So this is the broad spectrum which is covered in the 800 2007. Now, as we all know that the whole code is based on the concept of the limit state design method. And in limit state design, there are 2 kind of limit states which we need to take care. One is the ultimate limit state, and another is the serviceability limit state. So when we talk about ultimate limit state, it is nothing but it is a complete collapse of the structure. And for the serviceability limit states, these are the kind of states when we can say that now structure is not fit for its intended use. So generally in limit state design method, the concept is that the design should be based on the most critical limit state, and then it should be checked for the remaining limit states. So there is a concept of the probabilistic design in the limit state design method. So if you see in this figure, this blue color line shows the applied load, and the green color line shows the strength of the structure. And in the figure, we can see that there is a small overlap between the applied load and the strength. Now, this overlap is corresponding to the region of the failure. So in limit state design method, it is accepted that there is a probability for the failure of the structure. But by method of the reliability based design, we are reducing the probability to the acceptable minimum level. And we all know that in traditional working stress design method, the concept of failure was not accepted. So with this logic, now there are 2 terms, like one is the characteristic load and another is the characteristic yield, which is ultimate stress. So what we are doing in the design, we are increasing our load, and then we are reducing our stress by usage of the partial safety factors. Now, deflection limit table is now expanded in the latest code as compared to the earlier code, which was 1984 code. So now the deflection limits have been specified for the separately for different types of buildings as well as for the different members. Okay, so there are also 4 kind of cross sections which are defined in the code: plastic section, compact section, semi-compact section, and the slender sections. So as we all know that the plastic section can develop the full plastic moment as well as they can develop the full plastic hinge rotation capacity. In the compact section, they can develop the full plastic moment, but they do not have the adequate plastic hinge rotation capacity. For the semi-compact section, they can reach up to the yield stress, but they cannot develop the full plastic moment because there is going to be the possibility of local buckling. So this figure shows one of the example of the local buckling. And for slender section, they cannot even reach up to the yield stress. So because they will buckle because of the slenderness. So these are the 4 classification of sections now which are introduced in the code. Now code also specifies the different methods of analysis. See, generally what all majority of structures are being designed using first order elastic analysis method, correct? But code also specifies requirement of second order elastic analysis in certain cases, as well as there is also separate sections for the plastic analysis. Also, there is a separate section for the frame buckling analysis, just to ensure the stability of the steel structures. So as we were discussing in the earlier slide that there are limit states which needs to be checked for design of members. So if we talk about tension members, these are the 3 limit states which needs to be checked, like yielding of cross section, rupture of critical section, and the block shear. This is a typical figure for the block shear failure. So when we talk about compression members, there are 4 buckling classes are introduced now, which are based on the type of section and axis of buckling. So in the earlier code, it was just only a single curve. Now there are 4 different classes which have been introduced in the code. For the member subjected to bending, for that, again, there are 3 limit states which needs to be cross-checked. First is the shear leg, second is the flexural torsional buckling, and third is the shear buckling. And generally for normal I section, the most critical limit state will be flexural torsional buckling, which needs to be taken care. Now this figure shows the classical example of the elastic flexural torsional buckling. Now this is again a big subject. We are not going into much detail for this. Of course, we'll be having separate section on this, or maybe separate webinar also we can arrange on it. It's a big subject. But let's try to move fast for the overall area of the IAS 2007. Now, as we just discussed in the beginning, that code also gives an option for a working stress design method. So sometimes I have heard that since code is giving an option of working stress design method, sometimes it is understood that we can also design our structure using old code, which is IAS 1984. But in my opinion, the working stress design method, which is mentioned in 800/2007, is drastically different as compared to 800/1984 code. Because what is mentioned in 800/2007 code, that the all limit states, whatever we have discussed for the compression member, tension member, or as well as member which are subjected to bending, should be ensured even in the working stress design method also. The difference is only that the all limit state should be checked with the permissible stress and unfactored load format. Now this is interesting, correct? So there is a section 12 which is introduced, which talks about earthquake resistant design. And as we all know, and it is established fact that during seismic event, the structures is going to experience the deformation, which is beyond elastic limit. So to ensure the stability of the structure during the extreme event, there are different criteria which are being introduced in this section. Okay, so this was a quick recap of IAS 2007. So in summary, we can say that this is not a conventional revision of the previous code. There is a major change in the philosophy. The revised code is relatively more complex for performing the manual calculations as compared to the previous code. Because of that, there is a greater reliance of engineers on different software for performing the design calculations of steel structures. And also, as of today, the detailed handbook along with explanatory notes and practical examples is still not available with the practicing engineers. Okay, so this is the overview of IAS 800 2007. Now let's see part 2, which is IAS 800 2007 and the software. See, I generally define the code in two parts. It is my own analysis. That one is the simplified approach and another is the complex approach. So whenever we say the simplified approach, that means that it may err on the conservative side, and wherever we say it is a complex approach, that means more calculations are required. Now see, there are certain automated formula which is a part of, say, New Zealand code, American code, Euro code, even Australian code, but in the first revision of IAS 800 2007, like they have not become of the code. So because of that, they have not become part of the software. So let's try to understand what are the major difficulties which will occur because of this. So sometimes it is said that the design result or the material requirements are higher as compared to the working stress design method, as compared to the like 800 1984 code. Now it may be because of, in my opinion, that the simplified option is chosen against the complex option which is available in the code, but the complex approach which is available in the code might not have become part of the software. So while designing the member or structure, the simplified approach will be considered, and because of that, the structure may err on the conservative side. And we all know, see, now all projects are fast track projects. So generally we do not have time for carrying out manual and cumbersome exercises for optimization in the structures. So for that, this is the note which I have put, like whatever software we are using, those software need to be authenticated. Okay, so that concludes part 2. Now let's move to the part 3. So in part 3, what we have done, that we have referred IAS 800 2007 in detail, and the popular software which are available in the market, which we are using in the routine basis. Those software were studied in detail, and based on that, one list was prepared that these are the areas which may be included in the software, so that this gap, major gap, can be covered. And of course, this is not a complete list which we will be discussing right now, but I will be just highlighting few important or key areas which needs to be included in the software. And again, it is not only for a specific software, it is for the all popular software which are presently available in the market. See, there is a requirement of automatic calculation of notional horizontal loads. Now, the code says that 0.5% of gravity load should be applied as a horizontal load on the structure for ensuring stability of the structure. So in my opinion, these notional load should be calculated automatically by the software, and that analysis should be performed. We will see in coming slides why it is important to perform this analysis automatically. Now code identifies two kinds of frame. One is a non-sway frame and another is a sway frame. And now this is the equation which is given in the code, which defines the deflection requirement or deflection limit under effect of the horizontal notional loads. Now, for design of steel structures, the parameters can be divided in two parts. One is the moment amplification factor and another is moment reduction factor. And now these moment amplification factor and moment reduction factor are dependent upon type of frame. So if software is calculating automatically the horizontal notional load, they can identify whether it's a sway frame or it's a non-sway frame. And based on classification of sway frame, non-sway frame, the software can also identify that all these parameters like KY, KZ, CMX, CMY, because these parameters are dependent upon classification of frame. As per clause number 4.4.2, it is mentioned that if my KY or KZ is greater than 1.4, then second order elastic analysis is required, which is detailed out in annexure B. So if we talk quickly, what is the second order elastic analysis? Because generally we are performing only first order elastic analysis. Second order elastic analysis is nothing but the material will be completely elastic, but the load will be applied in an incremental way. So it will be applied on the deformed shape. So basically it's a geometrically non-linear analysis, but the material will be elastic in this analysis. And also the code identifies that if my elastic buckling load factor is greater than 5, then the changes in the effective stiffness of members due to axial forces may be neglected. So what is elastic buckling load factor? It is nothing but the buckling load for the structure divided by the design load. And if this ratio is greater than 5, then I need not consider the effect of axial force on the structure. So the note which I have mentioned here, that should be automated calculation for the elastic buckling load factor also. Now, this is most interesting. See, there are parameters like a C1, C2, C3, CMY, CMZ, as well as CMLT. Those parameters are dependent upon the variation of bending moment across the length of the member. So here we have taken two, three snaps, variation of bending moment across the length of the member. Okay, as we have discussed that these C1, CMY, CMZ, CMLT are dependent upon the bending moment diagram of the member. Now, bending moment diagram varies for a typical member for all load cases. And there are several thousand members in a typical industrial structure. So, it is impractical to define accurate parameters manually, considering variation of bending moment for all load combinations. True. So we will have to consider the conservative parameters if those are not being calculated automatically by the software. Now, slender sections. Okay. So for slender section, as we discussed in the beginning of the presentation, that these are the sections which will not be even able to reach the yield stress moment because they will buckle. Now, the Indian Standard Code allows two options for the design of slender section. One is the design as per IS 801, and there is another option which is by deducting the width of the compression plate element is in excess of the semi-compact section. So, in my opinion, these kind of two options should be added in the software. Okay. Presently, the errors are being displayed that now being a slender section, the design cannot be performed. Okay. Okay, this is most interesting part. what I mentioned here, that the option for consideration of seismic chapter like section 12 may be introduced in the software, because there may be structures for which section 12 may not be relevant. So as per the Indian Standard Code. So for those kind of structures, the option should be there with the designer, whether section 12 should be considered or section 12 should be ignored for the design. And also all relevant checks as per different types of frames like OCBF, SCBF, OMF and SMRF to be included. See, the code says that the frame should shown to withstand inelastic deformation corresponding to a joint rotation of at least 0.02 radians for OCBF and OMF without degradation in strength and stiffness below the full yield value. And a similar value is 0.04 radians for the SCBF and SMF. So for these critical clauses, the check should be included in the software for the above mentioned conditions. Okay, so this is just only glimpse of the areas which needs to be included in the popular software. Now, as we discussed in the beginning, that we have initiated few exercise. So I will present here the one of the exercise from the exercises which are going on. It is just a simple case study of a plane frame. So as you can see here, that there is a UDL and concentrated loads, and there are certain dimensions which are mentioned here. So what we did, first of all, we designed this frame with the popular software, and thereafter same frame we designed with the manual calculations and with a complex approach, and we identified all parameters manually. But in the software, the parameters which were considered like automatically, which was considered by the software. So we have considered default values of C1, CMX, CMY and CMLT are considered as per the software. And right now in this exercise, the effect of C2 factor is ignored because it is even not included in the software. So with this exercise, our finding is that the structure results are erring 30% on the conservative sides. Meaning the software is giving 30% of results on higher side. Now this value 30% is only specific to this example. Now if we change the load pattern, if we change the height, if we change the geometry, or even if we consider the value of C2 factor, this value can change significantly. But for the exercise under consideration, the outcome is almost 30%. Okay, so what we have discussed in the last slide, that there is an error on the conservative side, but there are also certain areas because of that the error can go on the unconservative side also. So definitely these kind of errors are simply not acceptable. And on the other side, if we are erring on the conservative side to a greater extent, then purpose of migrating from the working stress design method to limit state design method is defeated, in my opinion. And also from sustainability point of view, the optimum material should be utilized. Okay, so this brings us to the last slide of the presentation. Now this I have just put the way forward. Now this is the overall scenario which is there, but now what should be the way forward out of this? Like first of all, I have said that the software should be authenticated for use of limit state design method. We may prepare an exhaustive documents for popular software which highlight the clauses parameters are considered in totality and the parameters and details which are not considered in the software at present. And that should be available with the designer whenever they are performing design, so that they can also manipulate or they can adjust their design accordingly. Whatever queries or doubts we have related to Indian Standard Code, now that may be forwarded to BIS technical committee for further action, and the discussion can be initiated. Now, we group of engineers, as I said in the beginning, have initiated this exercise. So if you would like to join us, you can also definitely join us, and we can work together for this noble cause. So I'm sure you must be having so many questions in your mind with this topic. So so you can just note down my contact details for further doubts or queries if you want to send me. And also, as we just discussed in the previous slide, if you would like to volunteer for the activities related to IS 800 2007, you can just drop me a message on this contact details. Okay, and this was the first webinar which we launched from the Indian Association of Structural Engineers, Gujarat State Center. So your feedback is most welcome for improvement as well as for the upcoming webinars. Okay. So finally, we come to the question and answer session round. So what you can do, you can write your question in the chat box. Because of time limit, we may not be able to take all questions, but we'll be taking few questions and then we can discuss and debate offline also. Okay, you can write down if you have any questions or any feedback, any suggestions, you can write down, which we can discuss. Since it was a first webinar as well as the first subject which was considered, so it was complete overview. We didn't go into the technical detail of individual area, but that also we can go in the future subject. I think some question are coming now. What are the software based on IS 800? Okay, naam Sujan? Yes. Okay, Yash is asking that what are the softwares available based on IAS 800 2007. See, there is a STAT, there are so many software like in which it is being claimed that IAS 800 2007 is being followed, like STAT, there is a ETABS, and there are so many other software available. Yeah, certainly. Yeah, Vinubhai Patel is asking that the video should be mailed to all. Definitely, we have recorded and then we'll be sending to all of you. Even see, there is a limitation of participants. If you see on the screen, there is a maximum 50 participants which we can allow. But the responses what we received, that was in fact substantially higher. It was reached around 350 numbers. So definitely, we'll be sending to all of them the recorded video to those also who could not participate. Sumit. Okay, Sumit is asking that can we have webinar on 16700? Definitely we can have webinar on 16700. In fact, many engineers have suggested webinar on 16700 in the Google form. Our code calculations are as complex. Can't we use ASCE or other code as software based on that have incorporated values? Naam Sujan? Okay, Nikhil is asking that can we use different code like American code? See, I personally believe that if we are in India, we should use Indian code, correct? And we should try to find out the solutions. Like if we find practical difficulties, we should find out the technical solution, and then I think we should follow the Indian code. Because the overall philosophy, overall context, or like the all factor of safety and all parameters are based on the fabrication directions procedure or even raw material available in the particular country. So I believe personally that we should follow Indian code only. Yeah. What about non-linear? Okay, there are so many questions are coming here. I'm just trying to out. What about non-linear analysis like push-over analysis, or code doesn't consider this? Yeah, there is a question from Gopal, non-linear analysis is not considered. But see, if you refer IS 1893 part 4, it is said that you need to perform non-linear time history analysis to ensure the safe collapse mechanism of the structure. But that this is just only one statement made in the code. There is no elaborated procedure available in the code. So I'm sure that definitely the detailed handbook and guideline needs to which will come in the very near future, and based on that it can be performed. But now our all codes are going towards this non-linear dynamic analysis. Akshay is asking that are the code revisions updated in the software? See, this is the precise point which I want to make. The software are updated definitely up to certain extent, but there are certain gap areas which are not included in the software. So that engineers should be aware about it, because it is mentioned in their maybe help manual or maybe in the release guidelines it is mentioned. And we in fact what we should also do, that we should perform one small examples for authentication, like all critical clauses or like whatever changes which has happened in the code, whether that those are being incorporated or not. Yeah, just a minute. I'm reading out question. Yeah. Okay, the question is that what is the method for the faster calculations? You always, I personally believe that manual understand or like manual calculation and the behavioral understanding is the faster approach. And sometimes we can limit the modeling of the structure, like it can be divided in certain parts, and then we can use our past database also. But definitely it's a big question which we can separately discuss out. Which code works for steel bridges is only IAS 800 is used for this. Yeah, for steel bridges it is a different code. It is not. Yeah, it is a different IS code. Yeah, any more questions? Yes, welcome Jay. Okay, again questions are coming. I'm just reading it. You can open YouTube channel also. Yeah, certainly. See, what we will do, we will record this webinar, and this will be our first video for our YouTube channel, and then there is going to be series of such kind of videos. Yeah. Yeah, certainly we will be taking so many more topics. It was just the beginning. Yeah. See, what you should do when you are performing the any structural design, generally, first of all, you should not mix two different codes. Otherwise, the whole, because there is a change, in the complete philosophy. So if you are following 800 2007, then you should follow 800 2007 in totality. And when 800 2007 was released, so by default, now 800 1984 code is ruled out. Now it is superseded. Okay, still people are typing. So we can take a couple of more questions and then we can close it. Thank you, Pratik. I believe still a couple of questions are coming up.
Recently, IIT Bombay has launched OSDAG software for steel design. What are your reviews?
See, for OASGD software, personally, I have not reviewed it. But see, again, my stand is again same, like whatever software you have, it should be, what I would say, understood in totality, and then authentication should be done by using even simple examples, and then definitely we can start utilizing it.
Which are parameters should be considered for the analysis instead of?
Which parameters should be considered? Of course, it's I cannot answer immediately, but it's a big topic again, which we can discuss separately. But see, whatever parameter means, I think this is the point which I wanted to make, that software is using certain parameters as a default value, and then it is having certain impact on the structure. That for that, engineer should be aware. So you can always segregate that which are the critical parameters which is having significant impact on your design. So for those parameters, definitely you can have certain rigorous exercises, and the parameters which are not affecting your structures in to with a very significant effect, definitely you can use the default values of the software. Okay, thank you. Yes. Yeah, for 1893 and 13920 also, there are so many requests which came in the Google form. So certainly in very near future, we'll be taking a IS 1893 as well as IS 13920. Thank you, Gopal. Okay, then with this, we are closing it our session. And once again, thank you very much for participation in the first webinar from Indian Association of Structural Engineers, Gujarat State Center. And I hope that we'll be meeting again very soon online. Okay, thank you. Bye bye.